Hello and welcome to Security Methods and Practice CET 4884. In the last session, we reviewed the history of information security and identified some of the critical characteristics of information. The session addressed the need to balance information security with making the information available for the users but secured at the same time. The session introduced the components of an information system that need to be protected through having multiple layers of security in place. This session will continue addressing phases of the security system's development life cycle and the role of information security professionals in an organization. To implement information security in your organization, there are two main approaches, the bottom-up approach and the top-down approach. In the bottom-up approach, the system administrator identifies security issues and vulnerabilities and report those problems to the upper management to make the proper changes to improve the system or system security. Although this approach has the advantage of the technical expertise of the administrators, especially that they are dealing with the problem directly, it might not be supported by the upper management and decision makers. You are going to tell them the problem, but they're not going to act on it. And that is because of the lack of support that could be due to budget issues or priorities that might not be disclosed to the system administrator, to that person. So although technically you are identifying the problems, but you're not being supported, not because they don't want to support you, but there are other issues that's being, let's say, given priorities in the company more than the security issue or that issue. In the second approach is the top-down approach. In this case, the project is initiated by the upper management who issues policy, procedures, and processes dictating the goals and expected outcomes of the project and determine who is accountable for each of the required actions. Since this approach has strong upper management support, a dedicated budget and clear planning will be provided. These type of projects have high probability of success. The most successful top-down approaches also involves a formal development strategy referred to as a systems development life cycle, which will be addressed in the next few slides. This figure shows the direction of the arrows for the two approaches. The direction of the arrows shows the direction of the pressure for success and how it's being driven. The Systems Development Lifecycle, or SDLC, is a methodology for the design and implementation of an information system in an organization, which is based on defining system requirements, analyzing requirements, design the system, implement the new design or the recommended changes, then monitor and measure. This methodology is a formal approach to identifying security issues and solving system problems based on structured sequence of procedures that will continue in a loop. Using this methodology ensures a rigorous process and avoids missing those steps that can lead to compromising the end goal. The goal is creating a comprehensive security organizational profile. This approach consists of six general phases that will be explained in the next few slides. This diagram shows the waterfall methodology as one of the approaches to system development life cycle. The figure shows the 6 phases that system development approach goes through. The approach starts with investigating the system to determine system requirements. Once the system requirements and user requirements have been identified, we move to the next phase of analyzing system requirements. The next phase will be to design the new system logically and physically based on the analyzed requirements. The new design or the suggested changes will be implemented, and the system will be monitored to evaluate identifying or any new problems or opportunities for improvement, going back to the investigation phase. So it's a loop, and it keeps going as long as the system is running or in use. The recommended changes will be associated with a maintenance plan and change process. What will happen if I need to maintain the system? And what will happen if there is a change? How would I do the change? What will be the process for that change? In the system security or in the security systems development lifecycle, we can adapt the same phases used in the traditional system development lifecycle to support the implementation of security project. The fundamental process is to identify the security issues and problems within the system, including the threats. In addition, alternative solutions and specific controls can be identified to counter those threats. So basically, we can use the same approach, the waterfall approach, and go with the same loop and with the same 6 phases, but most likely we will be specifically addressing security. At that point, we will call it security SDLC or SIC SDLC. And the main purpose of the SIC or SIC SDLC is to unify the process of reacting to security breaches and make it a coherent program rather than a series of random, seemingly unconnected actions. Investigation is the first and the most important phase of the system development lifecycle. The investigation of the SIC SDLC begins with a directive form or from upper management dictating the process outcomes and goals of the project, as well as the constraints or limitation placed on each activity. The initiation of the process comes with a full study of cost-benefit analysis to evaluate the perceived benefits and timelines of the project. So already at this point, the upper management knows the security issues or even the proposed solution, the budget needed at the time of the frame to finish the security update, and all other information related to the project. So at that point, all the information should be there for the upper management. Already they know that, and already they planned for that. So an organizational feasibility analysis is performed to determine whether the organization has the resources and commitment necessary to conduct successful security analysis and design. Could I do it internally? Do I have the team to do that? So I need to do a feasibility study to see if I have the capabilities, the skills, the resources within the company to do that. The feasibility study will include a statement of program security policy that outlines the implementation of security changes. Teams of responsible managers, employees, and contractors are organized, problems are analyzed, and scope of the project will be identified, including goals, objectives, and constraints not covered in the program policy. So if I don't have the team, if I don't have the resources available, then I need to contract a third party to do the job for me. In the analysis phase, the current threats and required controls identified in the investigation phase will be analyzed, including reviewing existing security policies and/or programs. The analysis phase also includes an analysis of relevant legal and risk issues that could impact the design of the security solution, and a recommended mitigation plan will be developed. The logical design phase creates and develops the blueprints for security, and it examines and implements key policies that influence later decisions. Also, at this stage, critical planning is developed to identify the actions required to respond to partial or catastrophic loss incidents. Analysts generate estimates of costs and benefits to allow comparison of available options. With all the known parameters, a feasibility analysis will determine whether the project could be executed by the company's IT team or need to be outsourced. If the company does not have the resources and skills required to complete the project, of course, a specialized company, as we mentioned before, will be recommended, or a third party will be recommended to work on the project and complete the project. In the physical design phase, the organization should identify the technologies needed to support the implementation of the new security system, which includes hardware, software, and network. The selected components are evaluated based on a make or buy decision. So also even the parts, the components, do need to develop those in-house or purchase from a vendor. Alternative solutions are generated and the final design is agreed on. Criteria needed to determine the definition of successful solutions is also prepared during this phase. Included at this time are the designs for physical security measures to support the proposed technological solutions. At the end of this phase, a feasibility study should determine the readiness of the organization for the proposed project, and then the champion and users are presented with the design. At this time, all parties involved have a chance to approve the project before the implementation phase or the implementation begins. In the implementation phase, security solutions are acquired, made or brought, tested, implemented, and tested again to make sure that it's working as intended. In this phase, educational programs will be developed to be used in the employees' training process and awareness process. Employees will be trained and educational programs will be developed for that kind of awareness. The new system design and the implemented changes will be documented, and those will be used as part of the training process. The implemented security solution will be presented to the upper management for performance review and acceptance test. The maintenance and change phase is the longest and most expensive phase, which consists of the tasks required, all tasks required to maintain and modify the system during its useful lifetime. So we're not talking about just a certain period of time where we do maintenance and that's it. We are talking about as long as the system is working, as long as the system is serving, we need to maintain that system. We need to do changes and modify as needed. So all these information should be planned for, and a budget will be assigned for that maintenance and that modification. Hackers are using new and sophisticated ways of attacking companies' information system. So repairing damage and restoring information is a constant duel with an unseen adversary. As new threats emerges and all threats evolve, the information security profile of an organization requires constant adaptation to prevent threats from successfully penetrating the system and putting their hands on sensitive data. Even after completing the current security projects, the security system development lifecycle continues, and the process begins again to identify new threats and new security issues as they appear in the system. The new system should be agile to accept security updates and to adapt with technological advancements. Many organizations believe that security should be addressed during the design and creation of the system. The goal will be to include procedures to create a software that is more capable of handling threats and attacks. A software that will have security as one of its major components. This approach is known as software assurance, and software assurance initiative supported by the U.S. Department of Defense and Department of Homeland Security resulted in publication of Secure Software Assurance, which is a common body of knowledge that has all the information needed. So we have lots of publications and documentation that will address these issues. The SWA, the Book of Knowledge, serves as a strongly recommended guide to developing more secure applications. It is a work in progress. It will continue also to improve and to be updated as needed to address all issues or related to security. And it contains the following sections: the nature of dangers, the fundamental concepts and principles, ethics, law, and governance, secure software requirements, secure software design, secure software construction, secure software verification, validation, and evaluation, secure software tools and methods, secure software processes, secure software project management, acquisition of secure software, and secure software sustainment. The software was designed and developed with security in mind. The software will be able to handle any threats and withstand any possible attacks. Some of the design specifications that will keep software within security principles are keeping the design simple and small as possible, accessing decisions that are designed by permission, not by exclusion, making the software check every access for authorization, making that design of accessing the software based on position of key passwords, adding a protection mechanism that require two keys or two verification factors to unlock the software, making sure that programs or users utilize only necessary privileges, and making human interface easy to use to users, so users routinely automatically use protection mechanism. Microsoft has their own approach to the software development lifecycle when it comes to security. The Microsoft SDL has 7 phases. It starts with training the developers and the design team, which is the core security. We need to teach them the core security requirements first. So those teams need to know what kind of security and security issues need to pay attention to. Then the team will start collecting system requirements and creating the quality threshold of each function that will include performing security and privacy risk assessments. In the design phase, the design requirements will be established, making sure that the software will withstand threats through attack analysis and threat modeling. Once the design is complete, the team starts with the implementation phase using approved tools to eliminate unsafe functions and analyze the course code prior to compilation to ensure that secure coding policies are being followed. Next, the team will perform dynamic analysis, which is performing runtime verification of the fully compiled or packaged software, checks functionality that is only apparent when all components are integrated and running, and then perform the fuzzing test, which is a systematic way to find defects in code that accounts for the most severe of security bugs. Fuzzing is capable of finding remote code executions such as the buffer overruns and permanent denial of services such as the unhandled exceptions, read AVs, and threats or thread hangs, and temporary denial of service such as leaks and memory spikes. With the release of that software, an incident response plan will be created, which will help addressing new threats that can emerge over time. The plan should include who to contact in case of a security emergency and establish the protocol for security servicing, including plans for code inherited from other groups within the organization and for third-party code. At that point, the release will be certified and archived. The created incident response plan should be tested to measure the results and adjust the response plan as needed. In small businesses, one or more ITs might admin the network, maintain computers, and work as security professionals. In large organizations, it takes a team of professionals with a wide range of expertise and different skills to support the organization information security system or programs. To develop and execute specific security policies and procedures, additional administrative support and technical expertise is required. Starting from the senior management the organization needs, we can see the ranks or the specific roles. For example, the Chief Information Officer, who is identified as a Senior Technology Officer and might also be recognized under other titles such as the Vice President of Information or Vice President of Information Technology or Vice President of Systems. The CIO is the one responsible for advising the Chief Executive Officer, President, or company owner on the strategic planning that affects the management of information in the organization. Another individual who might be recognized is the organization or in the organization is the Chief Information Security Officer, who is responsible for the assessment, management, and implementation of securing the information in the organization. So we could have somebody who's specialized just in information security and will be specialized for securing the information. It may be also, we may refer to them as the manager for security or the security administrator or a similar title. The information security project team includes individuals who are experienced in one or multiple areas of security, whether technical or non-technical areas. Starting from the top down, the team will include the champion, who is the senior executive who promotes the project and ensures its support both financially and administratively at the highest levels of the organization. So it could be the CIO or the Chief Information Security Officer. The team leader, and that's the project manager, who may be a departmental line manager or a staff unit manager, who understands project management, personnel management, and information security technical requirements. Security policy developer or developers, those are individuals who understand the organizational culture, policies, and requirements for developing and implementing successful policies. And we have risk assessments specialists, and those are people who understand financial risk assessment techniques, the value of the organization assets, and the security methods to be used. So basically, they will translate the problem or the risk into a cost and impact on the company. What would that do to the company and financial situation of the company? Security professionals, and those are dedicated or trained and well-educated specialists in all aspects of information security from both technical and non-technical standpoints. And then we have the systems administrators, and those are people with the primary responsibility for administrating the systems that house the information used by the organization. And at the end, we have the end user. And the end user, those whom the new system will most directly impact because they are going to use the system. So ideally, a selection of users from various departments, levels, and degrees of technical knowledge will assist the team in focusing on the application of realistic controls applied in ways that do not disrupt the essential business activities they seek to safeguard. So it's good to have their opinion, and they will give you the feedback on how the system being used, what kind of problems they face, and how it can be fixed. So you can provide them with the how to be fixed based on their use and their experience. The most important part of the system that needs protection is the data that will be entered, used, or utilized and stored. Data that has critical information. Part of the team will own and safeguard the data, while another part of the team will use it with different levels of access. Based on that, we can identify 3 entities in the system that will be directly related to data as part of their responsibility. First, the data owner, who is responsible for the security and use of particular set of information. Data owners usually determine the level of data classification associated with the data, as well as changes to the classification required by organization change. Data custodian, who is responsible for the storage, maintenance, and protection of the information. The duties of the data custodian often include overseeing data storage and backs up, implementing the specific procedures and policies laid out in the security policies and plans, and reporting to the data owner. And then we have data users, and those are individuals who are at the end of the system, who work with the information to perform their daily jobs supporting the mission of the organization. Everyone in the organization is responsible for the security of data, so data users are included here as individuals with an information security role. That's why we need to provide them with the proper training so they know how to deal with data and how to secure their information, their passwords, their ability to get into the system. With large organizations, each organization develops and maintains its own unique culture and values. Within the corporate culture, there are communities of interest. This includes information security management and professionals, information technology management and professionals that will be just for technology. So we have the security and the information security, we have the information technology in general, and we have the organizational management and professionals. One of the questions that might be asked about information security is do we consider it as an art or science? Looking at the complexity of information systems, the implementation of information security has been described as a combination of both art and science. Designing the system is considered an art that differs from one person to another, and there are no set in stone constraints or rules that regulates how you install various security mechanisms. You use those mechanisms. You can buy them, but the implementation for those mechanisms, it's up to you. So it's a design, and each company's design may be different from the other. Actually, you cannot find many universally accepted complete solutions that can be used as standard template to follow. It's not like one design fits all. The design of each organization system differ with the organization requirements and culture. While there are many manuals to support individual systems, once these systems are interconnected, there is no magic user's manual for the security of the entire system. This is especially true with the complex levels of interaction between users' policy and technology controls. At the same time, we consider the implementation of information security as science that has been developed by computer scientists and engineers, a technology designed to perform at rigorous levels of performance. In addition, there are some scientific conditions that cause all actions that might happen in computer systems. Almost every fault, security hole, and systems malfunction is a result of the interaction of specific hardware and software. With the feedback from computer users, developers, we can improve the system and resolve or even eliminate these faults. There is a third view that can consider security as social science. Social science examines the behavior of individuals as they interact with systems, whether societal systems or, in our case, information systems. Since in a security system, people inside the organization interact with the developed system by understanding how they interact or behave, security administrator can reduce the risk. Based on the known behavior, security administrator can develop a plan to mitigate any security issues. From your personal opinion, which one do you think is more accurate? Is security an art, security is science, or security is social science? Think about that. I will leave you with this, and this will be all for this session. If you have any questions, please let me know. Have a great day.